Welcome back to Math Dogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Today's topic is some college algebra word problems. This is part 1 of the video series. We have 12 practice problems and examples to work out with you. Remember, we believe math is better with your dog, so call your pups. Let's get started. Problem number 1 asks you to translate to an equation and solve. It says 5 times a number increased by 12 is 57. So as with any word problem we work out, we like to break it apart according to the language. And one of the first things I try to do is find the equal sign, especially if I have an equation. In this case, I'm going to look for words like is equal to, is the same as, and in this problem, I have the word is. So I know that's going to be my equal sign. That's going to separate the expression on the left side from the expression on the right side. And the expression on the right side is pretty straightforward. It's just the number 57. The expression on the left side is a little bit longer, and so I'm going to have to look again for key words to break that apart. So I'm going to read it again. 5 times a number. Well, I know the word times indicates multiplication, and I know a number indicates a variable. So that would be 5 times x. The phrase increased by indicates addition, and the word 12 is just the number 12. So now I have my equation, 5x plus 12 equals 57. Now all I have to do is solve. The left side is simplified and the right side is simplified, so I'm going to subtract 12 from both sides in order to get the variable term all by itself. 12 minus 12 is 0, 0 plus 5x is 5x, and 57 minus 12 is 45. Now I'm going to make the coefficient of the variable term equal to 1 by dividing both sides by 5. 5 divided by 5 is 1x, and 45 divided by 5 is 9. And so x will equal 9. Problem number 2 is again a type of problem to translate to an equation and solve. It says 4 less than 3 times the sum of twice a number and 7 is 12. So, like I said, as with any word problem, I want to break it apart, and one of the first things I'm going to look for is my equal sign. There's the word is. That's going to separate the left side expression from the right side expression. And in fact, I know the right side expression is 12. So this equation will be equal to, and I'm going to have a 12 on the right side. The left side expression is a little more complex. It says 4 less than 3 times the sum of twice a number and 7. So let's break this apart. There's 2 key words in translation that flip the way that the expression will be written. Those key words are than and from. If I see the words than or from, what's written first in words gets written second in symbols, and vice versa. So this says 4 less than, here's the word than. So I know at the end I'm going to be subtracting 4. 4 less than, and 4 is going to be less than 3 times the sum of. Here's another key phrase, sum of. The sum of means I'm going to include a set of parentheses. Sum of, difference of, quotient of. And what I do is I look for the next word being and that will tell me the 2 things that are being added together in the sum. So I want a sum of twice a number, which is just 2x, and 7. So I'm going to open up my set of parentheses, and I'm going to sum 2x and 7. So notice I have the word than. The 4 is written first in words, but second in symbols. Then I found sum of, difference of, product of, quotient of. That means you're going to need a set of parentheses. Look for the word and, sum of twice a number and 7. Here's the last part of my translation. I want 3 times the sum, and so I'm going to multiply that sum by 3. Now I have my equation. 3 times 2x plus 7 minus 4 equals 12. Let's simplify the left side using the distributive property. 6x plus 21 minus 4 equals 12. I still have like terms in 21 minus 4, so 6x plus 17 equals 12. Now I'm down to what I call the two-step. I'm going to subtract 17 from both sides and divide by 6. So 17 minus 17 is 0. 0 plus 6x is 6x. 12 minus 17 is negative 5. Now I'm going to divide both sides by 6. 6 divided by 6 is 1x. Negative 5 divided by 6 is not a clean division, so I'm just going to express that as a fraction. And so my answer would be x equals negative 5/6. Problem number 3 is also translate to an equation and solve. However, this time there's variables on both sides. The problem says 4 times the difference of a number and 9 is 7 times the number less than 8. So again, I'm going to go on a search for keywords. I try to find my equal sign first by looking for phrases like is equal to, is the same as, and I have the word is right here. So there's my equal sign. That's going to separate the left side expression and the right side expression. So now I'm just going to focus on the left side expression. I'm going to look for words like than or from, or sum of, difference of, product of, knowing that I have to open up a set of parentheses, and I'm going to connect that word of to the word and, so I know what the sum, difference, product, etc. is. So it says 4 times the difference of a number and 9. There's no than or from, so what I see is what I get. I'm going to write it in the order, but I do see the phrase difference of, so then I'm going to look for the word and, so I know what I'm subtracting. I'm going to subtract a number and 9. So I'm going to open up my set of parentheses, and I'm going to subtract a number, which is just a variable, and 9. In the front of that, I have 4 times that difference. So I'm going to have to multiply the entire difference by 4. That completes the left side expression in the equation. The right side expression says 7 times the number less than 8. And here I see one of those key words, than. So 7 times the number will be written first in words, but second in symbols. So that's going to be minus 7x, 7 times the number. And the word 8 is written second, but it will be written first in symbols because the words than and from are the only 2 directional words. Otherwise, what you see is what you get, and the order it's written is the order that you write it in symbols. So now I have my equation. 4 times x minus 9 equals 8 minus 7x. I know they're simplifying with the distributive property on the left side. That will give me 4x minus 36 equals 8 minus 7x. Now I'm going to have to collect my variables all on one side and my numbers on the other. I could subtract 4x from both sides, or I could add 7x to both sides. I'm going to choose to add 7x to both sides in order to keep my variable term positive. So 4x plus 7x is 11x minus 36. Negative 7x plus 7x is 0. 0 plus 8 is 8. And now I'm down to that 2-step. Add 36 to both sides and divide by 11. So I'll add 36 to both sides. Negative 36 plus 36 is 0. 0 plus 11x is 11x. And 8 plus 36 is 44. Last step, divide both sides by 11 to make the coefficient 1. 11 divided by 11 is 1x, and 44 divided by 11 is a clean division of 4. So x will equal 4. Problem number 4 is also translate to an equation and solve, except this time it involves fractions. It says 2/5 of a number is 16. So let's go through the process. Here's the word is. That's going to be my equal sign, and separate the left side expression from the right side expression. I see the right side expression is just the word 16, so that's just going to be the number 16. The left side expression says 2/5 of a number. So there's no than, there's no from, so what I see is what I get. That's the order that is written in words will be the order in symbols. It doesn't have a sum of, difference of, product of, but it does have the word of. And this word of indicates multiplication. So I'm going to multiply 2/5 by a number. And remember, a number is just the variable. So I would have 2/5 times x, or 2/5 x, and that will equal 16. Since this equation has a fraction, to solve it, first I'm going to clear the fractions by multiplying both sides by the least common denominator. In this case, that's 5. So 5 multiplied on the left side, 5 multiplied on the right side. 5 divided by 5, 5 goes into 5 once. 1 times 2 is 2x, and 16 times 5 is 90. Now all I have to do is simply divide both sides by 2 in order to make the variable coefficient equal to 1. 2 divided by 2 is 1x, and 90 divided by 2 is a clean division of 45. And so x will equal 45. Problem number 5 is again translate to an equation and solve, except this time it's going to have fractions on both sides. It says the sum of 3 and 1/5 of a number is 2/3 of the number subtracted from 14. So there's a lot of words going on in this problem. However, I'm going to follow my process. First, I'm going to find my equal sign. Here's the word is. So I know that's going to be my equal sign, and it's going to separate the expression on the left side from the expression on the right side. The expression on the left side says the sum of 3 and 1/5 of a number. So I'm going to look for the words than or from to see if there's a reversal, no than or from. Then I'm going to look for words like sum of, product of, different of, quotient of, in order to know that I have to open up a set of parentheses. And here I have the sum of. Sum of, then I look for the word and. That's the of and combination. So I know I'm adding together 3 and 1/5 of a number. And so that's going to be the phrase on the left side. It's going to be 3 and 1/5 of a number is 1/5 x. Now in this case, the sum is not being multiplied by anything on the outside, so I really don't need parentheses, but I always get in the habit of, if I see sum of, difference of, quotient of, I open up the set of parentheses and write my sum in there. The right side expression says 2/3 of the number subtracted from 14. Well, here's the word from, so I know there's going to be a switch. 2/3 of the number is written first in words, but will be written second in symbols. 2/3 of the number, of indicates multiplication, so that's going to be minus 2/3 of the number would be x. Subtracted from 14. Well, the word 14 is written second in the expression, but the number 14 will be written first because of the word from. Now I have my equation. 3 plus 1/5 x equals 14 minus 2/3 x. Since there's fractions, I'm going to multiply both sides by the least common denominator, which in this case is 15. So 15 times 3 will be 45. 1/5 times 15, 5 divides into 15 3 times. 3 times 1 is 3x. And that will be equal to 14 minus 2/3 x times 15. 15 times 14 is 210. 3 divides into 15 5 times. 5 times 2 is 10x. So now I have to gather up my numbers on one side and my variables on the other. So I'm going to choose to add 10x to both sides in order to keep my variable term positive. 45 3x plus 10x is 13x equals negative 10x plus 10x is 0. 0 plus 210 is 210. Now I have a two-step. Subtract 45 from both sides, divide by 13. So subtract 45 on both sides. Positive 45 minus 45 is 0. 0 plus 13x is 13x. And 210 minus 45 is 165. Divide both sides by 13 to make my coefficient equal to 1. 13 divided by 13 is 1x. And 165 divided by 13 is not a clean division, so I'll just express that as 165 over 13. So x will equal 165 over 13. Problem number 6 asks you to find two numbers that are related. It says a larger number is 5 less than 3 times the smaller number. Their sum is 11. Find the two numbers. So while these problems might seem confusing, what we're going to do is we're going to break it into two steps. And both steps actually involved translation, like we worked on in the first few problems. The first step is to translate in order to find the numbers that we're looking for, what's called defining the variables or defining the unknowns. The second step is to use translation to write the equation. So let's look at the first sentence. A larger number is 5 less than 3 times the smaller number. So I have two numbers that I'm looking for, and they are related to one another, a smaller number and a larger number. I'm going to call the smaller number x. That's usually the easy part. You're always going to define one of the unknowns as x. Now we're going to translate to find the larger number. So it says a larger number is 5 less than 3 times the smaller number. So we see the word than, which means we already know that's going to switch the positions from words to symbols, and it says 3 times the smaller number, which we called x. So that's going to be 3 times x, and 5 less would be minus 5. So I used translation to write an expression for each of the unknowns. Now I'm going to use translation to write the equation. This is the sentence. Their sum, meaning the smaller number plus the larger number, is 11. So the smaller number x plus the larger number 3x minus 5 is 11. So I found my is, which is the equal sign. The left side is the sum, which means we're adding them together, and the right side is 11. So now I'm just going to solve. First, I'll combine like terms. 4x minus 5 equals 11. Now I'm down to a two-step. Add 5 to both sides and divide by 4. So negative 5 plus 5 is 0. 0 plus 4x is 4x. 11 plus 5 is 16. We'll divide both sides by 4 in order to make the coefficient equal to 1. 4 divided by 4 is 1x, and 16 divided by 4 is 4. So x would equal 4. Which means my smaller number will equal 4. My larger number will be 3 times 4 minus 5, or 12 minus 5, which would equal 7. So the smaller number is 4, and the larger number is 7. Problem number 7 also asks you to find two numbers that are related. It says one number is 5 more than twice the first number. If triple the first number plus 7 is equal to double the second number, what are the numbers? So again, we're going to use translation twice. First, to write an expression for the variables or unknowns we're looking for, and secondly, to write the equation so that we can solve it. So if I look at my first sentence, it says one number is 5 more than twice the first number. So my first number, I'm going to call x. Remember, you're always going to call one of your unknowns x. The second number, I'm going to use translation to find out what expression I can write for it based on what I've already defined the first number as. So it says one number is 5 more than twice the first number. So the other number, I'm going to have addition because it's more than. Twice the first number means 2 times that number. So that will be 2x plus 5. Now I'm going to use translation to write my equation. It says if triple the first number plus 7 is equal to double the second number, what are the numbers? So just like I did in the first few problems, I'm going to find my word is. There's my equal sign is. So the left side will be triple the first number plus 7. So the first number is x. Triple x will be 3 times x plus the 7. Here's my equal sign is. Double the second number. Double means 2 times. Well, the second number is 2x plus 5. So I want 2, and I'm going to open up a set of parentheses because 2x plus 5 is an expression of the second number. So my equation would say 3x plus 7 equals 2 times 2x plus 5. Now I'll go through the equation solving process. The left side is already simplified. However, the right side has a distributive property. 2 times 2x is 4x, and 2 times 5 is 10. Now I'm going to gather all my variables on one side and my numbers on the other. I'm going to choose to subtract 3x from both sides in order to keep my variable positive. So 3x minus 3x is 0. 0 plus 7 is 7. 4x minus 3x is x. Plus 10. Now I'll subtract 10 from both sides. 7 minus 10 is negative 3. 10 minus 10 is 0. 0 plus x is x. And my coefficient is already 1. Remember, there's a hidden 1 there. So x is equal to negative 3. Now I can find my numbers. The first number is x, and x itself is negative 3. So I know the first number is negative 3. For the second number, I'll substitute negative 3 for x. 2 times negative 3 plus 5. 2 times negative 3 is negative 6 plus 5, which is negative 1. So my first number is negative 3, and my second number is negative 1. Problem number 8 asks you to find two numbers that total. It says the sum of two numbers is 25. If 3 times the first number is twice the second number, find the numbers. So in two numbers that total problem, there is actually a trick to defining your variables or writing expressions for each variable. But once you know the trick, you'll be able to define them. And it's actually a pretty common structure in math problems. We have two numbers, the first number and the second number. Well, the first number is easy. One of the numbers is always going to be x. It's the second number that we have to use the trick for. So let's think about a piece of wood or a small little board that's 25 inches long total. If I cut a piece off, what's left is going to be 25 minus whatever I cut off. For example, if I cut off 1 inch, what's left would be 25 minus 1, or 24. If I cut off 2 inches, what's left would be 25 minus 2, or 23 inches. So if I cut off x from the board, what's left would be 25 minus x. And so my second number is always going to be the total 25 minus the first number, which we'll always define as x. The second part is just translation. It says if 3 times the first number is twice the second number, find the numbers. So I have my word is, that's my equal sign like we did in the first few problems. The left side expression is 3 times the first number. Well, the first number is x, and 3 times that would be 3x. The right side expression says twice the second number. Well, the second number is 25 minus x, and I want 2 times that. And remember to put it in parentheses because the number itself is represented by 25 minus x. And so my equation says 3x equals 2 times 25 minus x. And now I can solve. The left side is simplified. The right side has a distributive property. 2 times 25 is 50. And 2 times negative x is negative 2x. Now I'm going to gather my variables on one side and my numbers on the other. So I'm going to add 2x to both sides to keep my variable positive. 3x plus 2x is 5x. Negative 2x plus 2x is 0. 0 plus 50 is 50. And now I'll divide both sides by 5 to make my coefficient 1. 5 divided by 5 is 1x. And 50 divided by 5 is 10. So x equals 10, which means my first number is equal to 10. My second number is going to be equal to 25 minus 10. So it's like I cut 10 inches off the board. The second number would be 25 minus 10, and my answer would be 15. So my first number is 10, and my second number is 15. Once you know the total trick, you'll always be able to define both of the numbers. Problem number 9 also asks you to find two numbers that total. It says two numbers total 33. 9 more than 5 times the first number is equal to the second number. Find the two numbers. So it says that the two numbers total to 33. So we're going to use the total trick. The first number we're going to represent as x. The second number we're going to use the total trick. The total is 33 minus the first number, which would be x. So now I have the first number represented as x and the second number represented as 33 minus x. Now I'm going to use translation. 9 more than 5 times the first number is equal to the second number. So here's my word is equal to, that becomes the equal sign. The left side is 9 more than 5 times the first number. So more than means addition. I want 5 times the first number, and I want that added to 9. So 5x plus 9. The right side expression is just the second number, and we called the second number 33 minus x. So my equation says 5x plus 9 equals 33 minus x. And now I can solve. I'm going to gather all my variables on one side and my numbers on the other. So I'm going to add x to both sides in order to keep my variable term positive. 5x plus x is 6x plus 9. Negative x plus x is 0. 0 plus 33 is 33. And now I just have a two-step. Subtract 9 from both sides and divide by 6. So 9 minus 9 is 0. 0 plus 6x is 6x. And 33 minus 9 is 24. I'll divide both sides by 6 in order to make my coefficient equal to 1. 6 divided by 6 is 1x, and 24 divided by 6 is 4. So x equals 4, which means my first number is 4. My second number will be 33 minus 4, or 29. So my first number is 4, and my second number is 29. Problem number 10 is consecutive integers. It says the sum of three consecutive integers is 63. Find the numbers. So consecutive means one right after the other, and if they're consecutive integers, that means they're all one apart. So my first number that I'm going to define a variable for is x, just like we've been doing. Now I need to write an expression for the second number and the third number. So the second number will be 1 away from that, which means I'm going to add 1. So that will be x plus 1. The third number will be 1 away from the second number, or x plus 1 plus another 1, and 1 plus 1 is 2. So that would be x plus 2. Now I'm going to write my equation. I want to find the sum of these. So the first integer is x, plus the second integer is x plus 1, plus the third integer is x plus 2. Here's my word is for my equal sign, and that has to total to 63. Now I'm going to solve my equation. I'll simplify the left side. X plus x plus x is 3x plus 3 equals 63. And this just becomes a two-step. I'm going to subtract 3 from both sides. 3 minus 3 is 0. 0 plus 3x is 3x. And 63 minus 3 is 60. Now I'll divide by 3 to make my coefficient equal to 1. 3 divided by 3 is 1x, and 60 divided by 3 is 20. So I know my first integer is 20. My second integer will be 20 plus 1, which is 21. And my third integer will be 20 plus 2, which is 22. So my first number is 20, my second integer is 21, and my third integer is 22. Now there's other ways to solve this particular type of problem, but it helps to be able to define all three of your variables, because as you'll see in the next two problems, sometimes the equation becomes more complicated. So I know my answers are 20, 21, and 22. Problem number 11 is consecutive even integers. It says two numbers are consecutive even integers. 6 more than 5 times the smaller integer equals 4 less than 3 times the larger integer. Find the integers. Well, all even numbers are 2 spaces apart on the number line. And so I have my two numbers that I'm going to need to define variables for. The first number, or first integer, is going to be x, just like we did in the last few problems. The second number, this time since they're even integers and they're all 2 spaces apart, will be x plus 2. And now I have to write the equation. So in number 10, some people use tricks to find the answer to that problem, and they work for that particular type of problem. But if you don't have variables defined, you're not going to be able to write equations for these more difficult problems. So it says 6 more than 5 times the smaller integer equals 4 less than 3 times the larger integer. As long as I have my integers defined, I can go through my translation process and write my equation. So here's the word equals. That's my equal sign. The left side expression is 6 more than 5 times the smaller integer. So here's more than, which means addition, and I want 5 times the smaller integer. So that would be 5x plus 6. The right side expression says 4 less than 3 times the larger integer. So here's the word than. Even though 4 is written in words first, it will come second in the expression. And I want 3 times the larger. So that's going to be 3 times, and the larger one is represented as x plus 2. So my equation would say 5x plus 6 equals 3 times x plus 2 minus 4. And now I can solve. The left side expression is simplified. The right side expression has a distributive property. 3 times x is 3x. 3 times 2 is 6 minus 4. I have one more step to simplify the left side expression. 6 minus 4 is 2, so that would be 3x plus 2. Now I'm going to gather my variables on one side and my numbers on the other. I'll subtract 3x from both sides to keep my variable positive. 5x minus 3x is 2x plus 6 equals 3x minus 3x is 0. 0 plus 2 is 2. Now I'm down to a two-step. Subtract 6 from both sides and divide by 2. 6 minus 6 is 0. 0 plus 2x is 2x. And 2 minus 6 is negative 4. Divide both sides by 2. 2 divided by 2 is 1x, and negative 4 divided by 2 is negative 2. So I know my first integer is negative 2. My second integer will be negative 2 for x plus 2, and that will be 0. So my first integer is negative 2, and my second integer is 0. Problem number 12 is consecutive odd integers. It says two consecutive odd integers are related. 3 less than twice the smaller is equal to 3/5 the larger. Find the two integers. So just like consecutive even integers, consecutive odd integers are also 2 spaces apart on the number line. And so when I define the variables or the expressions, it's exactly the same expressions as it was for even integers. The first integer is x, and the next odd integer will be 2 away, or x plus 2. So notice the 2 is an even number, and I'm dealing with odd integers, but the 2 represents the space on the number line, not the integer I'm looking for. Consecutive odd integers and consecutive even integers are both 2 apart, and they're always defined the same way. Now I'm going to use translation to write my equation. It says 3 less than twice the smaller is equal to 3/5 the larger. So here's my is equal to part. That's my equal sign. 3 less than, here's the word than, so I'm going to reverse the 3. It's written first in words, but second in symbols. Twice the smaller will be 2x. So the left side expression will be 2x minus 3. The right side expression is just 3/5 the larger, which means 3/5 times the larger of the 2 is x plus 2. And so my equation says 2x minus 3 equals 3/5 times x plus 2. So now I'll solve the equation. Since I have a fraction, the first thing I'm going to do is multiply both sides by the least common denominator, which in this case is 5. So 5 times 2x is 10x. 5 times negative 3 is negative 15. 5 divides into 5 once. 1 times 3 is 3 times x plus 2. Now I'll simplify the right side expression using the distributive property. 3 times x is 3x, and 3 times 2 is 6. Now I'm going to gather my variables on one side and my numbers on the other. I'll subtract 3x from both sides in order to keep my variable term positive. 10x minus 3x is 7x minus 15 equals 3x minus 3x is 0. 0 plus 6 is 6. And now I'm back to a two-step. Add 15 to both sides and divide by 7. Negative 15 plus 15 is 0. 0 plus 7x is 7x. And 6 plus 15 is 21. Divide both sides by 7. 7 divided by 7 is 1x. And 21 divided by 7 is 3. So my first integer x is equal to 3. My second consecutive odd integer will be 3 plus 2, which would be 5. So my first consecutive odd integer is 3, and my next consecutive odd integer is 5. So that's it, part 1 of the college algebra word problems. Keep working hard, keep practicing. We know you can do this. As we say at Math Dogs, you got this.